Hi everybody, this video is to show how to program the Lattice Ice40 FPGA on this new little UPDuino board. It's like an Arduino board for FPGA with a Raspberry Pi. It's very easy to do, and all you need is a Raspberry Pi, the UPDuino board, and some jumper wires between the 0.1 inch headers. So I'll post the pinout description, hopefully in the video or at least in the description. But basically you've got power and ground running to the top header here. You've got one separate wire for the C reset line. This resets the FPGA during programming and loading of the SPI flash that's on the board, which also can load the FPGA. And then your SPI, just regular serial peripheral interface wires to this lower 6-pin header. To power up the Raspberry Pi, you're going to need a micro USB cord. That will power it up. You're also going to need an HDMI cable to a monitor or a TV. And then you're going to need an SD card, and you're going to need to load that with the OS. I'm using, I think, Raspberrian. I just follow the basic examples online. And on gnarlygrey.com, where the UPDuino board originates, you can get instructions that include that information as well. Okay, I've powered up my Raspberry Pi with the UPDuino board connected, and I'm currently in the Raspberrian OS for Raspberry Pi. I've got the Guinea Programmer's C Programmer and Compiler Editor open, and you can get to that going to the Raspberry Pi start icon, programming Guinea Programmer's Editor. Once you have that open, you're going to want to open rtest.c, which is available at gnarlygrey.com. This is the set of C programming to program the UPDuino. It also includes Raspberry Pi _program.c. And what that is the RGB LED starter bit stream is included in that. It's basically a hex file included in a struct, and that allows you to program the UPDuino and light up the LEDs with a FPGA bit stream. Once you have rtest open, I don't think you have to have these other ones open to compile. I think it will grab them automatically as long as they're in the same build folder. You're going to want to set up the build commands. Once you do this, it should be set it and forget it, but just go to the build tab, and then you'll want to make sure that your your GCC compiler has the %E and %F if it doesn't already, and then you'll want to add sudo to the execute command. So just basically make it look exactly like this. Once you do that, you can click OK. And then you can go to build, compile, and then build. I don't know if you need to do both of those, but I always have, so you can try it out and see if you do. And then execute. Once you click execute, it's going to say that CDone is low, and then it's going to say running 1, 2, 1, 2. These are just checkpoints within the program. You can check the for loop and see what it's doing there. It's just once it starts saying 3, that's passed through the loop, and the RGB LED should start blinking on the UPDuino board. Once you program the FPGA using the program we just showed, you'll see the RGB LED light up, red, blue, and green. That means it's programmed. That's the bit stream we loaded. Next, I'll show you how to load other bit streams or synthesize the RGB LED bit stream, and that should give you a jump start into designing your own FPGA programs with the UPDuino board. This setup here with the Raspberry Pi and the UPDuino is really nice because it basically almost doubles the amount of I/O that you have available to your Raspberry Pi, and it does that with 0 to very little latency depending on the FPGA design and how you interface to the Raspberry Pi, and that's pretty nice. It's very comparable. Power-wise is comparable to a microcontroller, but you don't have the latency impact when you're expanding GPIO, and you get more IOs. So that's just one of the many obvious applications for this kind of setup for your maker or hobbyist projects. Thanks for watching, and stay tuned for new videos to come.